This particular one is going to be a little bit heavier than the other area relationships because mostly this is new to you. It also requires a lot of review out of the special right triangles, and so pay dear and close attention. First of all, we're dealing with the regular polygons. To be a regular polygon, you need to be equiangular and equilateral. That would be a square is equiangular and equilateral. That would be a equilateral triangle. It would be a regular hexagon or heptagon, or regular means all of the angles are the same and all of the sides are the same. And the cool thing is that those types of regular polygons can be easily inscribed inside of a circle. Now, because of that, I'm going to introduce some words that deal with circles, but now we'll deal with polygons. For instance, a radius. The radius of the circle in all of these cases is this little blue guy here. And there are other radiuses there, but all of those would be classified as radii. And not only radii of the circle, but radii of the square, or radii of the hexagon, or radii of the equilateral triangle. Of course, you already know what a center is, but maybe you are unaware that a regular polygon has a center to it as well. And then finally, a brand new term that sounds a little intimidating is the apothem. Now, the apothem happens to be the distance from the center to perpendicular side. And so these green lines here are the apothem. Now, what I want you to note here, let's see if I can move things around a little bit to highlight them, is that in this guy, I want you to see that an important relationship are these guys right in here, the radius, the apothem, and that this is half of the side. If you look at this guy here, similarly, now what's kind of cool here is this is a 60-degree angle down here, and so guess what's going to be talked about is that the apothem and the radius and half of the side, they are in a 30, 60, 90 triangle. You're going to need to bring back all of those good memories. This guy is a little upside down, but he's also okay. Here's that guy there that we're kind of interested in. And guess what? This is, of course, also a 30, 60, 90 triangle. This is half of the side, this is my radius, and this is my apothem. So what you and I are going to do for 10 minutes here or so is we are going to look at each of these relationships. Remember, our focus is area of these, and so I want to now kind of dig deeply inside of this. Let's first talk about some theory. First of all, you'll notice that when we cut up an equilateral triangle, using its center, we get 3 congruent triangles. And each of these is base times height divided by 2. In this case, I can change out the base and the height with the apothem. That's the height of these guys. And S is the side. So it's side times the apothem divided by 2. Now, with a little bit of coolness here, what I can do is I can say, hey, notice they all had 1/2. They all had the apothem involved. And if I was to take that out, what would be left is the 3 sides. Wait a minute, the 3 sides? Another word for that is the perimeter. This is a brand new formula for you of a regular polygon, which is if you take the apothem and you multiply it by the perimeter and divide by 2, you get the area of it. And the reason that works is because of the congruent triangles inside. Watch, this will also happen for the next shape. The exact same formula arrives even if it's a square as well. Now we have better formulas for the square than 1/2 the apothem times the perimeter, but let's just see how it works again. A square would create the 4 triangles. BH could be substituted by side times apothem in each of those, right? Side times apothem divided by 2 gets you this region. And with a little bit of factoring, we find out that it would be 1/2 the apothem times 4 s's, which is also known as the perimeter. So here is a brand new formula. This will calculate the area of a regular polygon, any of them. It's not so cool. All right, let's dig deeper into each of these shapes and pay attention here because this is where we're going to review some key things. What's going to happen, and again, you can always find a square by side times side, right? S squared gives you the area. But sometimes they may give you information about the radius or the apothem, and you want to gather some other information. So just look, we're kind of looking closely inside of our guy to what's inside, and that's a 45-45. So when you kind of zoom in on the square's inner relationship between radius, apothem, and side, you find out that you're looking at a 45-45. Now, because of that, you and I know quite a bit. One, that our side here, the apothem, this apothem, and half of the side will always be the same value. So the apothem will always equal exactly half of the side, and vice versa. Or if you want to do that, 2 apothems will always equal a side. And you can see that, right, is that this guy right here is this, and if you double that, you would get an entire side. Also, let's review another cool idea. We learned in a 45-45 that we multiply by √2 to get the hypotenuse. So you need to remember that if you have this, we would multiply by √2, or we would divide by √2 to go back and forth. Let's show you a couple examples. All right, what did they give me? They gave me the radius is 10√2, and they would like the apothem. I know in a 45-45 I would divide by √2, and so the apothem would be 10, half of the side would be 10, and the whole side would be 20 if I wanted to know. What is the side of the square if the apothem is 7? Well, that would mean this is 7. Half of the side would be 7, and the full side of the original square would be 14, wouldn't it, because of that? Let's look at 2 more like this. This says the side is 24. Well, that would mean that this is then 12 right here. That would make my apothem 12, but they want to know the radius, so I would multiply by √2, and my radius would be 12√2. The radius is 12, and they would like to know the side of the square. So going this way, I divide by √2, which I've learned simplifies to 6√2. That would be only half of the side. The full side would then be 12√2, would be the value of that. Now let's put it all together to find area of the square. The radius, they say, is 3√6. This would be 3√6. So I got different ways to do this. Let's divide by √2. That would be 3√3. That would make this 3√3. It makes the side 6√3. Now, I could use the 1/2 the apothem times the perimeter, but in the case of a square, why would I do that when I could just say, quite simply, that the area of my square would be 6√3 times 6√3. And in doing so, I get 36 square root of 9, which, as you know, simplifies out to 108 centimeters squared. Let's move along. This time it says that my apothem is 3√6, and so that would mean this is 3√6, which means this is 3√6, which means this is 3√6, and so again my side happens to be 6√6 this time. So if I wanted to know the area, it'd be 6√6 squared. And with a little mathematics, you can get that one on your own, is 216 centimeters squared. Again, I'm not using the 1/2 the apothem times perimeter. I don't need to. I could. I'd get the same answer. My perimeter would be 6 root 6 times 4. That would be my perimeter. My apothem would be 3 root 6. But honestly, I'm in a square, and that's just kind of a redundant extra step or two that I don't need. Let's finish this up. It says my side is 7 root 2. What is my area? And in truth, again, I'm not going to play around. I'm just going to say 7 root 2 squared. And when you do that, you get 98 centimeters squared. Let's keep moving on to our next shape. Our next shape will be the equilateral triangle. It also sits nicely inside of our circle inscribed inside. Its inner shape happens to be a 30, 60, 90, and laid out in a particular way that this is half of the long side is the long leg is half of a side, the short leg is the apothem, and then the hypotenuse happens to be our radius. Now, that's that relationship, and so when we look closely at how that works, it says between the radius and the apothem would be double or half always, all right? And between the apothem and the half side would either be multiplying by root 3 or dividing by root 3. So again, this is where the tricky stuff comes in. It's the review of our special right triangle. In the first case, it says our radius is 10 root 2. What's the apothem? The relationship between hypotenuse and the short leg is to divide by 2 or multiply by root 2. So our apothem is just simply 5 root 2. Nice and easy. Over here it says what is the side if our apothem is 7. So our apothem would be 7. And you know that we would multiply by root 3 to get that. Now that, of course, is only half of the side. So our answer would be 14 root 3 would be the side of our equilateral. Continuing, just reviewing our relationships, it says the side is 10 root 3. That means this length would be 5 root 3. And to go to the short leg, from the long leg to the short leg, I divide by root 3. That works out nicely. That would be a 5. And doubling that to get my radius, my answer would be 10 centimeters would be the radius of my equilateral. Finally, the radius is 12, and they want to know the full side. Half of 12 is 6. 6 times root 3 is 6 root 3, and so the full side would be 12 root 3. All right, let's put it all together. My radius is 10. What is the area? So 10 is this. I know I'm in a 30, 69. This would be 5, and then this would be 5 root 3, and this would also be 5 root 3. I am going to use my new formula, 1/2 the apothem times the perimeter. My apothem is a 5, as I found out. And my perimeter is 10 root 3, 10 root 3, and 10 root 3, which is 30 root 3. And when I do the math on that particular item, that of course is 75 root 3 centimeters squared, and that is approximately 129.90 centimeters squared. And that's all we do, right, is just apply those relationships. Let's bring in a new one. This one says, what's the area if our apothem is 4 root 3? So 4 root 3, we multiply by root 3. That would be 4 root 9, but that's actually even a better number. That's just 12, isn't it? And this would be 12. So the area would be 1/2 my apothem times the perimeter. 1/2 the apothem is 4 root 3. And my perimeter would be 24 and 24 and 24, which happens to be 72, I believe. And I get 144 root 3 centimeters squared, which again is approximately 249.42 centimeters squared. I love how all of this stuff kind of connects together. The last one of this type says if the side is 6 root 3. Now if the side is 6 root 3, this little bit is 3 root 3. And when I divide by root 3, I get an apothem of 3. So I know that this is 1/2 the apothem times the perimeter. 1/2 the apothem is this. And my perimeter would be 6 root 3 times 6 root 3, or 6 root 3 plus 6 root 3 plus 6 root 3, which is 18 root 3. And that gives me 27 root 3 centimeters squared, or approximately 46.77 centimeters squared. All right, last shape, here we go. The hexagon also has a special triangle hidden inside of its guts. And again, we're going to need to use our 30, 60, 90 relationship to be able to pull this off. I do want you to notice that it is in an upright position, whereas the equilateral was laying a little bit differently. So in this case, again, the relationship has this look about it, which ultimately designates some of these relationships a little bit differently. This is the root 3 relationship between the apothem and the half side, and the double and half relationship go this way. So if you just take a look here, just quickly, you can see that the radius and half, or the double half relationship. And then between the half side and the apothem is the times root 3 or divide by root 3 relationship. All right, let's do the same thing we've done with the other ones, is do some quick relationships. It says the radius is 10 root 2, and they would like to know the apothem. So we would go this way, which would be half, so this would be 5 root 2. And then we would multiply by root 3. That would be 5 root 6 would be our value. Over here it says our apothem is 7 root 3, and they would like to know the side. So we would divide by root 3. That would give us 7, and we would add another 7 to get the length of the side for a total of 14. Let's see what our last two are here. It gives us a radius of 24. Well, half of that would be 12. And they wanted to know the side. Oh, whoops, I did that backwards. Let's just back up here. Hold on a second. Let's read it correctly. The side is 24, so that makes this 12. And they would like to know the radius. Whoop, it's 24 would be our radius. Our radius is 4, and again, they would like to know the side. So half of that is 2. And then I would add another 2, and we get our value. Let's finish up with the last 3. I know this is a long video. Really important stuff here, though. All right, our radius is 6 root 6. So half of that would be 3 root 6. And I would multiply by root 3 to get 3. Square root of 18 would be my apothem. So if I was doing this problem, I would do 1/2 the apothem times the perimeter. My apothem happens to be 3 square root of 18. Now my perimeter is 6 root 6. 6 root 6 times 6. This is my perimeter. This is my apothem. All of that is one big number, and that number is 324 root 3 centimeters squared. That's what it all simplifies down to. But truthfully, most of you will just slam that into the old calculator, and you get 561.18 centimeters squared. The key, again, is this magical little 30, 60, 90 triangle in here that needs to be used. Here we go. Next one. What do we give us? All right, they give us that the apothem is 3 root 6. That means I'm going to divide by root 3. That would be 3 root 2. And so my side is 6 root 2. I'm ready to calculate. That's what I love about this little formula. The apothem is 3 root 6. One of my sides is 6 root 2. But there are 6 of those, right? This is my perimeter. This is my apothem. All that turns out to be 108 root 3 centimeters squared. And that simplifies down to 187.06 centimeters squared, or approximately that value. All right, our very last question of the video. Here we go. we have a side that is 10. That makes this 5. That makes this 5 root 3. And we are good to go already. 1/2 the apothem times the perimeter, 1/2. Now the apothem is 5 root 3. Our side is 10, and there are 6 of those sides. There's my perimeter. There's my apothem. That simplifies to 150 root 3 centimeters squared, and that as a decimal is approximately 259.81 centimeters squared. Bingo.